Hi YouTube, I'm Pisces Keys, Instagram Pisces_AF, and what I'm going to be talking about today is the word kinetic energy principle. And also, this is my first YouTube video, so hopefully I'll do okay. I don't know. So first, what we're going to talk about is what is the word kinetic energy principle. So basically what it's saying is that if we have a particle and there's some force being applied to it, and that particle moves from point A to point B, of course that'll mean that there's some work going on here, and through that work the kinetic energy is either gained or is lost. Okay, I don't know if this wants to focus or not, so it's not focusing. So now what we're gonna do, sorry I had to close my blinds real quick, but we're gonna see how can we prove this mathematically. How do we know that if some force is being applied to an object, and that some work is being done on something, that the kinetic energy is gained or lost? So what we're going to do is we're going to think about Newton's second law of motion, force equals mass times acceleration. And from that we know that force is equal to the derivative of momentum with respect to time. So now we can multiply both sides by velocity. So we have velocity, force times velocity equals to dp over dt times velocity. Of course, these are all vectors. Now we're gonna have to relate this to kinetic energy in a way, because that's what we're trying to prove, right? That kinetic energy is gained or lost. So what we're gonna do is we're gonna come up to the side here. We're gonna take the derivative of velocity squared. Since we know velocity is a function of time, we can then say that this is equal to 2 times v times v prime. So now we're going to multiply both sides by m, because we want to fit kinetic energy in here in some kind of way. So we have d over dt of mv squared equals to 2mv v prime. And now we're going to divide both sides by 2. This cancels out, of course. So now we're left with d over dt mv squared over 2 is equal to mv. So if you look closely, you see that this is mass times velocity prime. Let's write it out in this way. So over here we have the derivative of momentum with respect to time. We know that this would be equal to mass times velocity prime, which is what we have here. And mass times velocity prime times velocity is, of course, mass times velocity prime times velocity. So here we see that this, which is also this, is equal to d over dt mv squared over 2. And we know, of course, that this is kinetic energy. So we say the derivative of kinetic energy, which is also going to be denoted by t, is equal to mv prime v, which is also the same thing as dp over dt times v. So we can go right back over here and say that force times velocity is equal to the derivative with respect to time of kinetic energy. Now, something that we also will notice here is that velocity is actually the derivative of the position vector with respect to time. So we rewrite it this way. And of course, the dt's cancel out. So we're left with F dr is equal to dt. Now what we can do is integrate both sides. So that means we have the integral of force with respect to the position vector is equal to the difference in kinetic energy from one point to another. So this actually verifies that when work is being done on a particle, that the kinetic energy is gained or lost. And there we have it. That is our work kinetic energy principle. Thanks.